features the talk entitled Galaxy, the Ultimate Enigma of Cosmology. Surely an exciting exploration of the mystery of our universe by one of our Malaysian most renowned scientific minds. Tanpa melengahkan masa lagi, the moment we have all been waiting for, izinkan saya berkongsi sedikit latar belakang tentang penceramah kita pada hari ini. Beliau pernah menubuhkan planetarium negara, mengetuai agensi angkasa negara, angkasa, serta memainkan peranan penting dalam pelaksanaan program angkasawan pertama Malaysia. At the international level, she served twice as the director of the United Nations Office for Outer Space Affairs, UNOSA, and also as Deputy Director General of the United Nations Office at Vienna. Sumbangan beliau dalam bidang sains mendapat kegemaran dunia, and in 2021, she was conferred the title Sansri for her outstanding contribution. Today, she continued to share knowledge, promote STEM education, and inspire the younger generation to look at the sky with curiosity and wonder. Hadirin sekalian, please join me in welcoming our first Malaysian astrophysicist yang berbahagia, Profesor Emerita Tan Sri Dato' Sri Dr. Mazlan binti Osman. Will be sharing her talk entitled Galaxy, the Ultimate Enigma of Cosmology. Thank you. Sorry, for our life. For your life. Yes. Thank you. It's honor. Thank you so much for inviting me, Professor Zawawi, to give a talk today. Actually, I'm here because okay, may I introduce to you Dr. Ramli Ibrahim. Ramli, please stand. You will understand why I brought him here today. But for this first part, I'd like to expose you a little bit to some of the problems facing the world of cosmology, astrophysics, astronomy, or even physics, you know. And what we will, you will, I hope you'll be able to appreciate that what the astrophysicists are going to find out from studying the galaxies will change the physics in your textbooks in the future. So people think that the study of astronomy is irrelevant to you, but I assure you that astrophysics is leading the world of knowledge today. There is nothing that is not touched by what physicists and the astrophysicists in particular are talking about. So I'm going to expose you to that through a discussion on galaxies. So I gave Dr. Zawawi, I gave Dr. Zawawi a series of slides just so you, I know some of you have never heard what is a galaxy before, so I hope you did Google it before you came, but okay, never mind. So can I have my first slide? You have to understand that I have been on the road from Penang and whatnot for a while, so I haven't had much time to collect all the beautiful slides that I know you would like to look at. But okay, can I, forgive me if I just tell, I thought I gave it in some order, but I think it's not in that order now. Can you show me the slide of the classification of galaxies? Ini baca sekolah macam my first year lecture lah ya. Huh? Oh, okay. Back or what? Front? Okay, this would be my first lecture in the, okay, see, oh, where am I? Where? Here. Okay. Before this, I have that first, that is a classification of galaxies. Before this, ada satu lagi.
Okay, even the video, about the video, we start out with the video, I think, yeah. Because it tells you why this is all a mystery. While the video is on, I'm going to look for that slide, okay? Yeah. No. Yes. Okay, that one. Okay, this one. Yes, I see. Okay, I sent a few.
Yeah, only these two.
Only these two.
Yeah, Chakawala and Kabul.
That's all. Because I sent. Just, show the video, please. This one, and then, or I didn't have it. Okay, looking at it is okay. Kuatkan sikit lah, berapa? Tak boleh kuat.
High-yield discussion galaxies based simply on their appearance. He divided galaxies into three basic forms: ellipticals, spirals, and irregulars. The Newtonian form diagram and the Hubble's basic arrangement is still in use today. Elliptical galaxies.
Memang tak ada. I'm sorry, but memang tak ada. Okay. Then this one will be next. Then I will show this next. Then I show this too. Okay, fine. I'll just change that.
Roughly spherical swarm of stars called a bulge. This bulge looks similar to an elliptical galaxy, but spirals differ from ellipticals because the special spiral galaxies use their spiral-shaped arms. Unlike spirals have a long size. Star formation in spirals is similar to a fractal shape in the state. Spirals through the wall, concentrating star-forming gas and dust along the inner part of their spiral arms. This traffic of matter is so dense that it gravitationally collapses, creating new stars. Spiral galaxies are subdivided into unmarked and marked and organized by the size of their central bulge and outside their outer round. Bronze forms of spiral galaxies when star orbits become unstable and stretched out. As the orbits lengthen, they create a bar. Bar grows as gravity captures more nearby stars. Irregular galaxies don't fit into the other categories. They are shapeless and have no symmetry or ordered structure. Irregulars may fill with old and young stars and often have lots of gas and dust forming new stars. Astronomers have expanded Edward Hubble's basic diagram to include galaxies that fall between these three categories. Intermediate spiral galaxies sit between unmarred and marred spirals and have a small bar. Lenticular galaxies sit between elliptical galaxies and spirals. They have a central bulge of stars and a flattened disk, but no spiral lines. Like ellipticals, lenticular galaxies don't have much gas and dust, and also have newly born stars. When viewed edge on, their shape resembles a lens, which is why they're called lenticular. Hubble's tuning fork was a first step in understanding galaxies and how they evolve. Observations by the Hubble Space Telescope will continue to improve our understanding of galaxies and their role in the evolution of the universe.
Okay, as I said, it's just to give you an astronomy 101 exposure to what galaxies are. And frankly, when I first started studying astrophysics or astronomy in university, that was a long time ago. Anyway, that was the idea on what galaxies are. And that tuning fork seems to imply that there is an evolution from one shape to the other. And I think when I was younger, I thought that was it. Um, and how to explain this evolution process. But of course, now with all the details that we are getting um, of the galaxies, I myself am not convinced it is an evolutionary track. It's definitely not an evolutionary track. Somehow, the circumstances under which the galaxies were formed, those are the ones that's going to tell whether it's going to be a spiral or a barred spiral galaxy, or even they call it ellipticals. There is a category just now that said irregulars. They, sometimes you think irregular lah, dia tak masuk any classification, buang je lah, But irregulars are the ones that are most exciting today. And I will tell you in a minute, I'll demonstrate why they are so exciting. So if you want to know what is the structure of the universe, have you ever looked up at the sky at night and think, where am I? Where are we? Where are we going? How is this in terms of a structure of the universe? It cannot just be what you see, right? And so all of this is, you can relate to it through your own religion, or whatever belief system you grow up in. But you will also think of it through your existential. If you have an existential crisis, you'll be thinking, where am I in this universe? But and what you have to see also, I don't have time to discuss it, but maybe when Ramli and I talk about Meniti Chakrawala, it will give you an idea on how you are connected to the universe. And it's really quite fantastic how you are connected to the universe. But that universe I'm talking about now, I'm not talking about anything else. That's how we think it looks like. It's not that we took a photograph of this, please, because we haven't even gone out of our own Milky Way. So these are all theoretical. I mean, so not theoretical, but we have data. So we have data of galaxies, galaxy positions, and when we position them, they look approximately like this. So we live in a universe that, like tendrils, like this cobweb. So I don't know what you're thinking, how the universe looks like, but that's what it looks like. It's like a cobweb of galaxies. So every dot you see there is a galaxy. Don't think about stars. The stars are too small in our discussion today. And so I can show you a lot of other beautiful slides like this, but that's what the universe looks like. Now, if I go to my next slide, sorry. Then I showed you all the different galaxies, but with better telescopes, with better AI, where we can look at data and analyze the data. Usually the eyes cannot see, but AI can see better. We found new types of galaxies. And when we look at these galaxies, what do they remind you of? They remind you of the irregulars. So remember I said, don't throw away the irregulars just because they don't look nice, because they are actually the key to the evolution of the universe in its youngest stage. These are the galaxies that are giving astronomers sleepless nights. And these are the galaxies where some people take advantage of it and say, oh, the Big Bang Theory is gone, finished. It's no longer true. So if you read anywhere that says that the Big Bang Theory is no longer true, please don't believe it, because people like to sensationalize it. Because when we astronomers adopt a theory or throw away a theory, and this is in science, in all of your scientific fields, one person does not tell you whether the theory is on or off. One observation cannot do it either. It's over years and years of plodding to find more data, to find more people to disprove what you're saying, more people to prove what you're saying. This is what science is about. When you're saying something and nobody cares to say you're right or wrong, then people are ignoring you, and that's very tragic. Because what you want to do is, if you're writing a paper in the future, and you will be in Nature or somewhere, everybody wants to tell you you're wrong. Or then there's some people who tells you you're right. But the more important is, who is saying you are wrong? Those are the people you make friends with. You find out, why do you think I'm wrong? And he will tell you, no, this data is like this, and from my own thinking, it's the other way, because then that's the only way science science expands, science improves. So we start in science with the words, I don't know. And when you say I don't know, then you have to think, right? How is it going to make you know? That is science. And that is all of philosophy. That is also sociology. You see a sociological phenomenon and you ask, why is that? I don't know. So you have to find out. It's the same in any field of knowledge. So these are the galaxies right now that look not beautiful at all. They are the exciting things happening right now. And okay, so this is just another pretty picture that shows you how I wanted to show you this. I should have shown you earlier. If you hold a 5-cent, a 10-cent coin in your hand at a distance of your arm, that is the picture that you see here. So you can imagine what the rest of the universe looks like. It's almost, and this is another mystery and to be solved in astronomy. Why is it so regular? Why is it, the word is isotropic, in a way that wherever you look, the universe looks approximately the same. And in trying to research, we don't know why it looks the same. So when we try to find out why it's looking the same, it's why we have all this Big Bang and other theories. So any picture is not just a pretty picture. You need to find out why it's looking like that. And astronomy, we use that, pretty pictures. So, then, okay, now, okay, wait, before this, yeah. So these are the galaxies right now that's screaming at us. And why are they so important right now? Because according to our Big Bang Theory, galaxies shouldn't be formed. We shouldn't be looking at galaxies until the universe is about maybe just under 1 billion years old. Our galaxy, our universe is 13.8 billion. Observable universe is 13.8 billion years old. We don't know the exact later on, because these are the galaxies that tell us that actually they were formed only a few 100 million years after the Big Bang. Okay, you see, Maslan, what is this 100 billion, 100 million, 1 billion? What is the problem here? It's old, But the problem is our physics tells us if the Big Bang happens at this point, matter will come into being at this point, energy and everything. And then we think, because of all the matter that's around, galaxies will be formed. And that, according to physics, will be close to 1 billion years old. But what's happening with these guys, So we have to revise to say, oh, maybe we were wrong. That process could be wrong. And the physicists think that they can describe exactly, almost exactly what happens to the universe after 3 minutes after the Big Bang. 3 minutes before too is too confusing for us. We cannot describe. But there's plenty of books out there you want to buy. 3 minutes after the Big Bang, we can describe in detail how the temperature goes up to 10 million, then 100 million, then 1 billion. This is what's going to happen. Helium, hydrogen is from helium, etc. You know. But maybe we need to rethink how we think, how we say the universe is evolving. Just by looking at pictures like this. But you know, I was saying just by looking at pictures like this, you know how we became able to look at pictures like this? It says there is the James Webb, JWST means James Webb Space Telescope, which was 10 years in the making. This is something about astronomy. You have to be very patient and stoic because anything you do has a 5-10 year plan. Example, just for those of you who want to become astronomers and astrophysicists, and I know that my talks normally make someone feel they have to do one. Pluto, we had lost pictures from Pluto, okay? I think you've seen them. It took that spacecraft 9 years to get to Pluto. So imagine if you were a PhD student, you are inventing this spacecraft with your supervisor or whatever, and you know you won't get any results until 10 years, 9 years later, maybe even 10. Because by the time you analyze the data, make sure it's correct, and other people tell you it's correct, and you publish, it could be 11 or 12 years. What I'm saying is that around astronomers, we are very patient. We are in for the long haul, whatever it is. You know, a relationship, anything at all. We are in for the long haul. So you have to be very, very patient. There are other ways I can tell you that you have to be patient when you're an astronomer. So what is happening with the universe? We don't know. But I want to show you one more thing. I'll end soon. So you think the universe is very calm out there, it's very beautiful. I've shown you pretty pictures, but actually we are. This is a very pretty picture. People like to use this as a demonstration of the beauty of the cosmos, but actually there's a lot of violence happening right there, and you can't see it because two galaxies collided. And that in the past, when I was growing up, looking at these things, to me, it's a violent universe. I remember giving a talk on the violent universe, but I don't think so anymore. I think these collisions are, quite nice because it is purely gravitational attraction, and I've come to look at it as making love, not not cannibalizing or eating up another galaxy. It's embracing another galaxy. But then that's because I'm getting old. I always like to think everything positively. But anyway, so I want to show you some pictures of this supposed violence. But look at that beauty, look at that beauty. I always tell my artist friends, you guys cannot even imagine what beauty looks like as God has created it. Um, you, you, uh, it's like almost impossible to imagine that is what is happening out there. My God, in those colors, those shapes. So if you haven't done that already in preparation for my talk, please Google galaxies and just keep going. Once you Google galaxies, you won't go to sleep. I guarantee you, because there's so much more to add. But galaxies are made of what? I'm going to end my talk soon. Galaxies are made of what? They're made of stars. Oh, now, how did stars form? Did stars form first before galaxies? Do we need to have stars first before they congregate to form a galaxy? Or did the galaxy form from some gravitational disparities or differences? I always say this, we don't know. And that's the lovely thing about astronomy, astrophysics. We just don't know. And yet, I know that whatever we discover will change your physics textbooks in the future. And I have done a little bit of not research, but I've looked at the last 10 or 15 years of physics Nobel Prizes. I think 80% of them are based on astronomy and astrophysics. So you see, there is a chance for you to win a Nobel Prize if you go into a new field like this. And here I will have to say that there's a field called gravitational astronomy where you're looking at the universe from the point of view of what you cannot see. So what are gravitational waves? They are like sound waves or even the electromagnetic waves, but it's all caused by presence of gravity. Again, look up gravitational waves. They're very nice examples of what it is. So one, I just want to say that if you switch on your TV like this, and you see this orchestra going to play, you have seen the conductor, very beautiful, and they're going to play music, whatever it is, Mozart, Bach, and then they start playing, and you don't hear anything. Then you're saying, thinking, what? Why? It's because you haven't heard the sound. To me, not being able to see gravitational waves, which is the very basis of matter, and we are all made of matter, is a tragedy because it's like us not switching on the sound when we're watching a symphony orchestra. So there are lots of things to discover through gravitational astronomy. I don't want all of you to be astrophysicists. I hope not. There are no jobs in astrophysics, but you can use this knowledge of astronomy, astrophysics to awaken your mind and your imagination. Ask yourself every time that you read or see something, what is behind all of that? And if I don't do anything else today, I hope to awaken you to question everything that you read or you see, or what people tell you, especially if you want to be scientists, because that's what we as scientists do. We question everything. Okay, so I said that Enigma of the universe. There are lots more enigmas. As I said, you won't sleep if you go through those. And I thank you very much for listening to me. And maybe I should introduce the next talk, Azari. Shall I? Okay. So, okay, you want to use the mic then? No, no, you can. Yes. Hmm. Oh, this is question and answer. Yeah, I have another second talk, which is yeah, it's about Meliti Chakrawala. But we can have a question and answer first. Yeah.
So, I have a question for you. So, my question is it's a bit of a combination of science and religion.
Sure.
So, let's have your
Oh, he was, yes.
Yes, it was very beautiful. The sound design, the answers is very cool. And he asked me of the different views, and he asked the so the different chemical science. It said it all started with yeah. So is it wrong to realize that God started the inquiry as a place of situations?
Okay, so this is your parents are getting their information like with Adam and Hawa from books like the Quran. Somebody will get it from the Bible, and it is perfectly okay for me, for you to believe that that's how the universe started. Some people believe the universe is only 6,000 years old, which is fine to me. I will not contest that. But what I would say to you is, despite what your parents are saying, that's their set of beliefs. Okay. Now you're the young person with information on on the internet or whatever books. You have to decide for yourself whether the Big Bang theory falls in line with certain beliefs. So what is your belief? And that's why I said to you today, you have to question everything that people are saying. Because sometimes, to me, things are said in terms of metaphors. Then you're not supposed to believe absolutely everything. And when the book, whichever book, most of them have this, says that God built the universe in 6 days, or in day one he did this, day two he did this. Question: what is the meaning of day? Do you know? Can you define day to me? Okay, 24 hours is one day. Who invented one day, 24 hours? Kita lah kan, with the calendar. How do you think we invented it? Because we go by the rotation of the earth one day. But what makes you think that the whole universe is predicated on the earth? Will it? Is it? Cuba fikir. So one day is 1 year on the moon, for instance, or on Mars. Different. One day is different. The way they rotate, and then 1 year is totally different for every planet. So whatever that is being said, 1 day, 6 days, is purely based on the Earth. We astronomers have moved out of this context that the Earth is the center of the universe for a long time. So, but I suppose some people still believe that the Earth is the center of the universe. But how can you think the Earth is the center of the universe? Look at the pictures I've shown you. It is not. So this is this is what we call it the Copernican principle, where we have been shown how unsophisticated our thinking is through the ages. So we think that the Earth is the center of the universe. Then with some observations by scientists, not necessarily scientists, some of them are arts people like Leonardo da Vinci and all that, Galileo, they discovered that actually not everything rotates around the Earth. So then we discovered that the Earth, rotate around the Sun. Then the Sun became the center of the universe. Then we discovered, oh no, the stars are all suns. And if that is so, then we cannot be the center of the universe. But we're just an average star. And we thought, okay, yeah, we are not fantastic anymore. Then we discovered galaxies. We thought, okay, in that case, our Milky Way must be the center of the galaxy. And then we discovered other galaxies. And then we discovered that actually there is no center in this universe. Especially it's not centered around us. Yeah. So it's because of the thinking, the observations, and actually it is collective, not wisdom, but what we think is the collective thought at that particular time. And it might change, as I said to you many times, Big Bang, we have James Webb images to tell us maybe it's not the Big Bang. And a lot of us are starting to think that we have multi-universes. There's not only one universe, many universes. So, you think the whole universe is based on the fact that from Adam and Hawa, when we are today talking about multi-universes. So think about it. I'm not saying your parents are wrong. They will have this set of beliefs, and I say I'm prepared. I'm prepared always to accept astrology, so many accept. But you got to speak for yourself. You won't get the answer from me. Okay. Is there another? Oh, no, no. It's just, me thinking in terms of knowledge we have to do. Okay? I think there's another question. Online? Ah, nice. Hi. We're back to aliens, Ramli. I knew you would be asking me about aliens. So let's start from the very beginning. Really, from the statistics first. You have to ask before you ask, is there life on this galaxy, that galaxy? Can life exist anywhere? Then you ask yourself, what is life? I'm always going down, 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 deep, deep diving of everything you see. So you define first, what do you mean by life? Life like you and me, I don't know, it's a miracle to me. It's a miracle that we all exist. There's so many things that have a billion and one things that could have stopped carbon from coming into existence, or oxygen, because that's what we are. But that's again another story. That is the universe designed for life? So can we detect is a good scientific question. Now, can we detect life is, first of all, before you look at other galaxies, you look at, can we detect life in other stars? Are there other solar systems? We call them stellar systems, because we know, because life exists around this sun, then yeah, great possibility life will also exist around another sun. So what did we do? We observe all the stars to see which ones of them have planets. If you have to start a planet, you cannot live on the sun. You can't on the star. Right? So you have to look for planets. And you know what? We have found thousands of planets outside our solar system. Again, if you want to find out, go look up exoplanets, EXO planets. It will give you all the information, beribu-ribu now. Stars, habitable ke tak, do they look like the Earth, do they look like Jupiter, do they look like Saturn, because those are ones you are familiar with. But there are planets out there you cannot imagine what they look like, or what environments they have. So once you have those, then we discover there are planets that could have water. So like us, we need water. And so if they have water, what do you want to do? You detect water on other planets. So that's the way you find out, can there be life in other galaxies? So you find out, yes, there is water in some planets. Okay, now you try to use that same principle. You go and look at other galaxies that I showed, and now our planet, our telescopes can do that a bit. We do better in our Milky Way. So if you find water on other planets, if you can see the planets in other galaxies, then maybe there is life. So I'm not answering whether there is or not. I'm telling you, what do you do if you want to find out whether there is life elsewhere? So you go by the basic principles. What makes life? And then you find out if life is what it is, then how do you detect it in other planets? Can you find planets outside of the solar system? Can you find planets outside of the Milky Way? And it goes like this. And it's not difficult. You just got to invent the telescopes. Okay, that's a yeah. Oh, okay. I'll try to be brief. Okay, what is it? This is online, okay? Online.
Yes. I don't want to say not.
Oh God, yeah, I always get scolded for this. You know, Joe scolds me all the time. Why is Pluto not a planet? This again is a consensus. There are many decisions in astronomy that we go by consensus, but we just don't make any consensus. It has to be based on scientific reasoning. So that scientific reasoning is what makes a planet. Again, you know, I'm asking you all these questions. What makes a planet? Then we look at the way the planets were formed right from the very beginning. And then when we look at the planets around us, this is what happened. So what happened was these, what we call, I suppose, conventional planets, like the Earth, Mars, Jupiter, they are in their orbit and they dominate that orbit. The word is you have to dominate that orbit, and meaning that very early on, as a planet, say I'm a planet, I clean up my orbit. I kick out the other smaller objects because I dominate in terms of my gravity. You know? Or if I don't kick you out, you slam into me and you become a part of me and the planet becomes bigger. That's what happened to the Earth and Mars and the others. Now, if you look at Pluto, it has many other objects almost the same size as Pluto. So if that is so, it means that Pluto does not dominate its orbit. There's so many other, what we call them now, oh my God, mini planets or something like that. There are thousands of them, not only in Pluto's orbit, but outside of Pluto's orbit. And so the astronomers say, if we call Pluto a planet, there are so many other minor planets as well. Minor planets that you have to give names to and say they are part of the planetary system. And because of that, they decided, no, Pluto is not a planet. But so there is a story on how we discovered Pluto. We think it is part of something that was purely coincidence. But no, Pluto is not a planet because there are hundreds of Plutos in that same orbit, which we have to give names to, and your textbooks have to change. It's not a good way to classify planets. I would be brief. Okay, just one more. Let's make it the last question. Let's make it the last one. The light from the sun reaches us, yes, uh-huh. And galaxies. Absolutely, because you know that light is velocity of light, speed of light is finite. It's about 300,000 kilometers per second. And so it takes time to reach us. So let's say Andromeda galaxy is 2 million light years away. So you times that 2 million times, I think, 10 to the 13 kilometers, which is what the speed of light, whatever, a light year. By the time the light gets here, it's already 2 million years old. So if you're looking at Andromeda, it's only 2 million years old. Those stars may not look the same. We think the galaxy would look possibly the same because we know from the evolution of galaxies, they don't change that much. They change over millions, hundreds of millions of years, not tens of millions. Only stars. Stars can evolve over tens of millions. But galaxies, no. But you can imagine you're always looking to the past when you're looking uh, into into the sky at night. You're looking at the moon as it is 8 seconds ago. You're looking at the sun as it is 8 minutes ago. So if somebody switched off the sun right now, we'll be happy here not knowing until 8 minutes later. They say, oh, where's the sun? but that's because of the speed of light. And that light's made up. Photons are so exciting. You think photons are boring? No, 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 no. Photons are so exciting. They don't know anything but time, space, sleepless nights. Yeah, I think that will be the last question. Did I bagi that video? Oh, thank you. Tunjuk Oh, I say.
We are moving to the next session. Hadirin yang dihormati, sebagai tanda penghargaan atas kehadiran beliau, izinkan kami menjemput yang terhormat kami Ibrahim menerusi Sutra Foundation dan tokoh seni negara yang telah menyumbang dalam memperkasakan seni persembahan tradisional dan moden. Menjemput dan Ibrahim.
This is something that I don't expect at all. I come to enjoy really creation toilets, and in the car, I'm still toilets need specialists. And I think you should speak to the literature person, you speak to me, the dancer, you speak to the astrophysicists, you speak to a politician, and you find that the world is really very, very important. And this is where Marisa was talking about. She wants to go back to the philosophy of philosophy of physics. So, in a way, I share very quickly the fact that in my dance, I happen to specialize in classical dance, which is Bharatanatyam from the south of India, and also Odissi from the eastern part of India. But I'm also a ballet dancer, and I work in Australia, and I did my movie actually. So I'm quite familiar to a certain extent with what it's talking. But I also am a Fulbright scholar, and I was very happy to find out that Madam Akiza is from Kelantan, and where I live, where the Kelantan government banned my role all those wonderful Malay art form, I thought that it's a form of Malay cultural genocide. So I was one of the people that said, look, I must go there and look at what is left, because of course it's declining. But I'm also a Fulbright scholar who did worked on the traditional psychotherapy healing, mainly looking at Magyo that comes out in my belief. And so the Malay concept of Semangat and Angin is really my opinion. But in my Indian classical dance form, I know that in the Natya Shastra, or the great treatise on dramaturgy dance, in the traditional sense, you cannot separate dance, drama, and music. And the fact that there is no concept, no axiom that cannot be expressed in dance. So that's a powerful concept. So we can express anything that is there, what Kansumaza was talking about in dance. That's why I also dare to metaphorically express that in a concept that is you find ambiguous, because the most interesting things in life is ambiguous, and the most boring thing in life is black and white. Okay, all right. So that's the thing. So even because I'm an expert in Indian mythology and concept, there was a point when we both talk about, as Razan was talking about the science of creation. I talk about the myth of creation. This is where things get very interesting in these 2 points. And let me tell you, in the Indian concept of Shiva as Nandaraja, and Shiva is this and this hand here. You can find that all that expresses everything in the image of Shiva. Okay, that he is staying, he has 4 heads, and he has both a drop, which symbolizes the first sound. And then it is quite possible that the creation starts with vibration. Yes. And the other hand, he has light, which symbolizes light, knowledge. Yeah. And he is around that symbolizes the cyclical, nature of creation. There is no beginning, there is no end. Then you can see that his hair is horizontal, which means that it is moving all the time. Nothing is static, as you see. The only constant is change. And one hand holds this. And meaning that, fear not, those who understand the metaphor, the symbol that is within this, is the one who is free from the conflict of duality. So these are all, if you go deep into dance, if you go deep in cosmology, you'll find that it's something very, very wonderful. And go deep into it, because you have Google, you have ChatGPT, but it is also very surface. But in order for you to go much deeper, and you have to really go much, much deeper than just the surface information knowledge. When the government of Trump and Denmark, that was the time when I went deep into the layouts and found the incredible storehouse of knowledge that is embedded in the way of performing arts, poetry and cosmology in that sense. And I find it so interesting. And I have a friend also, recently Dr. National Ball, and he was just who found the Buddha in the Buddha. So in fact, the moment he said that, he found that all of us went to Buddha for us to take a little bit to say that we have done, and also look at it. And he found of the science Buddha. And it was very interesting because I organized this talk. And well, Dr. Farid Al-Atas from the Al-Atas family asked the question, Dr. Rashra, what do the people believe at that time? Do they call themselves Hindus or Buddha or whatever it is? Because, all this language construct was made later. People don't call themselves Hinduism, people don't call themselves Buddhism, people just do whatever. So I think at that time also the indigenous people had other beliefs also, and also indigenous beliefs. So they are not strictly Hinduism, they are not strictly Buddhism, but they are also indigenous belief, because this is all before Islam comes into this is in the 26th century already. So this is very interesting. You all, that's what transhumanism was saying. We need to question points, because I think all of us cannot just take anything like that. Right? You need to question everything. Okay? Yeah. I won't. I'm here to follow online, and we have one of the things that I did was last night when we were there is I went to be the part where when afterwards I explained everything, I was in the audience, but this happened during our talk. Someone said, so once learning all that explanation, what about human life? What is the meaning of human life? So I think we just can you just repeat what you said? So I asked you, what is the meaning of human life?
Okay. To answer your question on the meaning of human, the speaker said, consider this. The universe is not only vast. You saw that to 3 elements in the universe, maybe more. And it could be like it could extend to 3,000. So with all of that, we don't even know everything that's in the universe. And we only know 5% of the universe. Like we should offer telescope flashlights on the years, we keep X-rays, but we only still know 5% because 95% is made up of what we call dark matter and dark energy. So we live in a universe which is unknown. In fact, we live unknowable because of the limitations of coordinates of the human race, just like the ant cannot conceive quantum mechanics. We humans cannot conceive what this actually universe is about into reality because of the limitation. Okay, so we don't have all of this. And so my question is, and we are so small that we really expect of us. And human existence is not only intelligent. My excuse is not to the blink of an eye in the lifetime of the universe. And so that's that. So do we ask what the meaning of matter in the universe that is unknowable? And so good side, that time, you missed the whole show. These are videos and that's this one is celestial objects are supposed to be let's slide. This draws the walls to the solution. But how to take Stay tuned to Unity Technology 2.0 with science and romance of the cosmos. See you on our next one tour, July 2025.
Thank you, Ms. and for sharing. Knows that our can connect with our cosmology. Okay, so we keep with the next section, which is benevolence in the life. Sebagai tanda kebahagiaan daripada Tuhan kepada pribadi. Untuk membuat semua syariat kita merupakan produk daripada fakulti sains makanan dan pemakanan dan akan disampaikan oleh yang berusaha ketua pusakawan Universiti Malaysia Sabah Encik Dawawi Datuk Haji Tiongin mewakili yang berbahagia Chancellor Universiti Malaysia Sabah. Majlis dengan segala hormat dan menjemput yang berbahagia Profesor Amerika Tan Sri Datuk Sri Dr. Mazhar Fikri Universitas untuk memberi pencucian sebagai tokoh pendukung atas kesudian beliau menyampaikan keramaian sangat membuka mata dalam bidang kosmologi. Terima kasih Tan Sri. Majlis juga ingin menjemput yang berbahagia Datuk Rami Ibrahim untuk menerima berhati kepada. Ladies and gentlemen, show our appreciation and okay, next session kita akan ambil gambar. Kita minta berapa lagi